Hi everyone, hey, Dr. Tom here, DIY Science Guy. Hey, so today we're talking about one of the most amazing molecules on the planet, sodium polyacrylate, or commonly called Waterlock. But when you look at it, it seems quite ordinary, even kind of boring. So it's this little white powder. I'll get a little bit out here. It looks like that sugary stuff that I put in my coffee every morning. But this little white powder has one characteristic that makes it truly amazing, and that's its ability to absorb water. Waterlock can actually absorb 700 times its own weight in water. So if I were a 100-pound chunk of this stuff and I jumped into a swimming pool, I would suck up 70,000 pounds of water from the swimming pool. And that pretty much seems like it'd be the whole pool to me. And so I know though, you want to see it, so let's go ahead and take a look at it here. So I have a glass of water, I have a half a teaspoon of sodium polyacrylate. I'm going to dump it in and stir it up. And really quickly, it absorbs that water in an amazing way, so I can take it now and turn my cup upside down. Look at that! Isn't that amazing? How can anything absorb that amount of water? And before sodium polyacrylate was invented, the best substance at absorbing water was able to absorb about 20 times its own weight in water, and then boom, all of a sudden we went to 700 times its own weight in water. So as it absorbs the water, it kind of binds it up and it forms this gel. All right, and if I take it and turn the cup over, kind of bump up and down, I can get it to come out of the cup, and it's sort of like Jello or a slushie, except it's not cold. It's just room temperature. All right, and this stuff is so good at absorbing water that if I stick my finger in it, it'll start to absorb water right from my body. So watch. Okay, I was just kidding. Of course it can't absorb water right through my skin, but maybe I fooled a couple of people anyway. So it turns out that Waterlock actually has a bunch of other useful properties too. And because of this, it's used for a whole bunch of different things that you might not even consider or you might not even think of. You know, so for example, it's definitely used a lot in soil as an additive to help the soil absorb water for new plants that are just developing their root system. And it's also used for a thickening agent for a whole bunch of different things like hair gels and soap, and even as a food additive for stuff like ice cream. So it's pretty amazing how many different uses there is for Waterlock. But Waterlock's most famous and most useful application by a long shot is in disposable diapers. And every disposable diaper in the developed world has Waterlock actually woven right into the fabric. And since every baby goes through between 3,000 to 4,000 diapers before they're potty trained, that means that the company that developed this stuff is making a boatload of money. And so for our experiment today, we're going to actually take a diaper and see how much water the diaper can absorb before it's saturated. And if possible, it'd be great if you could do the experiment with us. All you need to do is get a diaper, a couple glasses of water, and some kind of measuring device like a measuring cup. And if you can't do it today, you got to try it soon, because it's a super fun experiment and it's super interesting. And if you do it yourself, you learn a lot more and you remember a lot more. Okay, now I have my diaper and I have my little measuring cup and I have plenty of water here. So I'm going to start adding the water 2 ounces at a time or a quarter cup at a time, and then carefully add it to the diaper, and I'm going to see how much water that diaper can actually absorb. It's a really good idea to predict too how much water you think a diaper will be able to hold. I'm just kind of slowly trying to pour the water on different parts of the diaper. You can see my diaper's getting some weight to it already. Look at that. It's getting pretty heavy already. And so I think I'm getting pretty close now. Look how big and heavy that diaper is now. All right, and you can see why if a baby's swimming like in a little kiddie pool, and then the baby stands up with their diaper on, you can see why that diaper just sags down almost to the baby's knees. All right, I think the diaper might actually weigh more than the baby sometimes. All right, so hey, let's see, let's add a little bit more here. We're getting close. And when you get close, you'll start to see the water kind of getting on the sides and taking longer to soak in. I'm still not quite there yet. There's 15, pretty close now. Some of that water's collecting. I don't know if you can see it kind of right in there. And I'm gonna call this saturated now. It's pretty close anyway. So for me, I use 16 2-ounce cups. If I multiply that, that means 32 ounces of water absorbed by this diaper. That's 1 quart or 1 Gatorade bottle full of water that it absorbed. So that's pretty amazing. And if you're doing it at home, hey, email me and let me know how many cups that you were able to absorb with your diaper. And so guys, that's pretty much it for our science activity for today. I hope you liked our exploration with sodium polyacrylate and the diaper. And remember, if you like this kind of stuff and these kind of videos and activities, take a look at DIY Science Guy and subscribe if you find them fun and interesting. So take care, we'll see you soon.